Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Saifuddin bin Khairuddin. Okay, today I would like to present about my computational techniques project. The topic is about economic growth in the long run. Okay, now I will introduce a little bit about economic growth. Economic growth is like a big helper for a country to become better, and it really affects how people live, find jobs, and overall how good life it is. And this isn't just about the ups and downs that happen quickly, and it's about looking closely at what things are really important for making a country to grow well in the long run. And when we study this topic, we can see that how much money people save, the choice they make about investing, and the new technologies they use, all of these play a big role in how a country develops. So it is not really easy actually, and it is like a puzzle that leaders and researchers need to solve to make sure the countries can keep going better and getting better. Okay, the problem statement of this topic, sustaining long-term economic growth, is like a multifaceted challenge influenced by factors like capital accumulation, technological progress, and population dynamics. The interplay between these elements adds complexity, requiring policymakers to navigate nuanced decisions regarding incentive for savings, research policies, and demographic planning. And this research seeks actionable insights to guide nations towards sustained and inclusive economic growth, recognizing the intricate relationship that shape long-term development. Okay, for the literature review, capital accumulation. The accumulation of physical capital is like a critical driver of economic growth in the Solo Swan model, Solo 1956, and higher savings and investment rates leads to increased capital per worker, fostering economic expansion. And the second one is technological progress. Technological advancements play a pivotal role in the model, impacting productivity and economic growth. Innovations and improvements in technology are considered major contributors to long-term economic growth by Romer 1990. Okay, now for the methodology, how to calculate, how to foresee the method, we use the Solo Swan model methodology, and it involves solving a system of differential equations to analyze the long-term economic growth of a nation. And the model is integrates key factors including capital accumulation, technological progress, and population growth. And the differential equation describes the evolution of capital and output per worker over time. And the process begins with specifying initial conditions, such as the initial level of capital. Okay, by numerically solving this equation, the model captures the dynamics of economic variable, enabling the examination of steady states and traditional bases. And this methodology is provide a quantitative approach to understanding the determinants of long-term economic growth and offers insights into the interplay between the savings, the technological advancements, and demographic trends within an economy. Okay, now about the computational solution from the differential equation we get from the methodology of Solo Swan model. The differential equation is k equal to s multiplied with fk minus with delta plus n multiplied with k, and y equal to k multiplied with f prime k, where is the k is the rate of change of capital per worker, and S is the saving rates, and FK is the production function that represent the relationship between the capital and output, and delta is the depreciation rate, and N is the population growth rate, and Y is the rate of change of output per worker, and F prime K is the marginal product of capital. And this variable is the factor of the economic growth in the long run, because if anything change in the variable, so the economic growth will be affect also. So we transform this differential equation into the Wolfram uh, coding. So we get here beside this is the coding. So we assume that S is the saving rate is 0.25, the alpha, the capital share in output is 0.3, and the delta is 0.05, and the population growth rate is 0.02. Okay, so the initial condition, we put the initial condition, the years is in 100, the t is in 100. So and then we can get the result, the graph about the capital per worker and also the output per worker. So from this coding, we can get how the relationship between the capital per worker and output per worker for the economic growth in the long run. And then I will explain more about the graph in the discussion. Okay. Okay, now I will explain about the discussion about the economic growth in the long term. For the first one, it is the steady state. The steady state is by analyzing the solution to the differential equation that we get just now from the methodology, and we can identify the steady state of the economy. And in the Swan model, the steady state occurs when the rate of capital accumulation and output per worker reach a constant value over time. And as you can see in the graph in the slide, the value, the line is constant when it reach the steady state. The steady state value represent the long-term equilibrium of the economy. And the second one is the transitional dynamics. The Swan model is often exhibits transitional dynamics as the economy adjusts from an initial state to the steady state. It means from the bottom until rise to the above, right? And the plot results are the way to observe how capital and output per worker changes during this transitional period, and this provide insight into the convergence process and the speed at which the economy approach its steady state. And the third one is the effect of parameters, and we can experiment with different parameter values such as the saving rate, the depreciation rate, and the population growth rate. We can change the value to observe their impact on economic growth, because it is the factor of economic growth. And for example, if we increase the saving rates or the reducing the depreciation rate, it might lead to higher long-term capital accumulation and output level. And the fourth one is the long-term growth patterns, and the plot graph of capital and output per worker over time is provide a visual representation of the model's prediction for the long-term growth patterns, because in here we want to foresee the long-term economic growth. So is important for us to understanding how the changes in savings, population growth, or technology affect these patterns can offer valuable insights into economic development. And the fifth one is the sensitivity analysis. By adjusting the initial conditions and parameter values, we can perform sensitivity analysis to assess how the robust the model is to change in key variable, and this really help us in understanding the relative importance of different factors in determining economic growth. The factor is just now the saving rates, the depreciation rate, and the population growth rate. And the sixth one is policy implication. The result can inform policymakers about the potential outcomes of different economic policies. For example, they can evaluate the impact of policies that aim to increase the saving rates, promote technological progress, or control population growth. And then, in this mathematical coding, as you can see in the black side, the graph is identical. The shape of the line is identical, but the difference is the value, because in the black side the value is from 0 to 6. Meanwhile the blue side is the value from 0 to 15. And we can see the higher in the black side, I change the saving rate is 0.25. Meanwhile in the graph, in the blue side is 0.5. So we can see the higher the saving rate, the higher long-term capital accumulation and output levels, so the better the economic growth in long term. So we can just experiment by ourselves, change the value to foreseen what the economic growth in the long term. So it is very important and very useful to any government or any country to foresee their economic growth in the long term. Okay, now we have reached for the conclusion of the economic this topic about the economic growth in the long run. So the Solo Swan model, it's actually help us to understand what makes the economic growth in the long term, and it tell us that having more money, yeah, it is a capital accumulation, a better technology, or and a growing population are really important for economic growth. So the model also shows that the rules government make about things like saving money or using new technology, all of these can change how well a country does, and is like a tool that can be used to figure out what actually might happen when things like technology, the environment, and how rich or poor people are affect how well a country is doing. So the Solo Swan model is not just about the numbers. It is actually about the understanding what helps the countries to grow and do well in today's world. So I think that's all from me. So thank you.